Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
So for this question, if you want to find the frictional force, but they gave you acceleration, so you must solve it using the net force, because whenever there's acceleration, it involves net force. So you cannot just use the 12 newtons here to find the acceleration. So you need to find the net force. And to find the net force, the proper way is to draw a free body diagram first. So you can, besides the 12 newton they drew for me here, you can draw the friction, right? The friction backwards, which is what you want to find. But then some people ask me, what about the weight and the normal reaction? Now the weight and normal reaction, you don't have to consider it because your acceleration is to the right, which is horizontal. So you only need to consider the net force horizontally. So any vertical force, you can ignore. So now that you know the two forces acting are these two, so then your net force is MA. So obviously this must be bigger than this because it's accelerating to the right. So you take 12 minus friction equals to MA, and from there you can get your frictional force. So in this question, if you want to find out the force that X exerts on Y, right? If you want to find the force that X exerts on Y, so I want you to realize something. If I push X with a force F, it does not necessarily mean X is going to push Y with the same force. Now, why it won't be the same? Because the force that I exert must be big enough to push both of them to accelerate. But in turn, right, X will only have to push Y. It doesn't have to push itself because I'm pushing X. So the force that X exerts on Y will definitely be smaller than F. So how to find that force? So the technique, right, in solving this kind of question is first to take both objects together, combine into one. Now they did tell you the masses M and 3M. So I combine both of them into 4M. So the force I'm applying is F. So using Newton's second law, net force equals to MA. Now remember there's no friction because it's a smooth horizontal surface. So the only force acting is F, so that becomes my net force. So F equals to total mass 4M times A. Then what I'm going to do next is to make A as a subject. The reason why I make A as a subject is because when I solve even for individual objects like X and Y, the acceleration will be the same as this because they're moving together. So for example, since I want to find the force that X exerts on Y, so I need to draw the free body diagram for Y. So what are the forces acting on Y? The force that X pushes on Y. Now I wouldn't draw the F here on Y because Y doesn't know that I'm pushing X. He only knows that X is pushing Y. So I cannot draw the F on Y, I can only draw the force that X exerts on Y. And the mass is 3M. So the net force is Fxy equals to 3ma, and then the acceleration I can bring it back here because it's the same acceleration, and I get 3F over 4. But to prove to you Newton's third law is correct, the force that X exerts on Y will definitely be equal to the force that Y exerts on X. So I'm going to prove to you by drawing the free body diagram for X now. So there's a force F to the right because I'm pushing here. But don't forget, because X pushes Y, according to Newton's third law, Y must push back X. So I'm going to take this force as F that Y exerts on X. So therefore, the net force here will be 2, so it'll be F minus Fyx equals to the mass here M, because the mass of X is M, so Ma. Rearranging, making Fyx as a subject, I'll get Fyx, bring it over, from here I bring it over, Ma bring it over, so I get F minus Ma. Then the A, I can still bring it from here, and after I solve this, I'll get 3F over 4. So that proves to you that X, the force that X exerts on Y, 3F over 4, is exactly equal to the force that Y exerts on X, 3F over 4. So next time, right, if the question asks you, instead of the force that X exerts on Y, if the question wants you to find the force that Y exerts on X instead, you can find either one. It's the same. But you look at the working, right, which is actually easier. like CAIE, which one is easier, the force that X exerts on Y or force of Y exerts on X? X, X exerts on Y is easier because the working is easier. So therefore, you would use this all the time lah. Even though the question wants you to find the force that Y exerts on X, you can do that. Now, if you want to do question 10 on top here, so they say the mass accelerates uniformly. What does accelerate uniformly mean? It means constant acceleration, okay? Constant acceleration. Because some people, right, they misunderstand accelerates uniformly to mean acceleration increases uniformly. It's not. Accelerates uniformly is just constant acceleration, not increasing uniformly. When the resultant force, so from the formula F equals to ma, when your A is constant, your resultant force has to be constant. So the answer will be, what do you think, Ewan?
B.
B, well done. Now, if you have a force that's applied, right, freely moving object. Actually, freely moving object means what? No? That means the only force acting is force F, no friction. No friction means freely moving. So if there's no friction, the F that you apply will become your resultant force or your net force. So at one instant in time, the object has velocity V, acceleration A. So which quantities must be in the same direction? So this one, right, in Newton's second law, it mentions one. All right, I mentioned in the video before. So Kang Yu, what's the answer?
Acceleration and force, because they are directly proportional.
Yes, acceleration and force, well done. Because acceleration and force, which is resultant force, must always exist in the same direction. They are inseparable. So if a ball falls vertically and bounces on the ground, right, so which one is correct? Now, they didn't specifically mention it must obey whichever law, but as long as it's a correct physics concept, so you should be okay with it. All right, so Lester, what do you think is the answer?
B.
B, and Jasper? B also. Well done. Actually, the answer is B. Now, this is actually according to Newton's third law, because the force that the ball exerts on the ground equals in magnitude and opposite in direction to the ground exerts on the ball. So remember, Newton's third law must fulfill three conditions if you're describing Newton's third law. Number one, the force must be equal in magnitude. Number two, opposite in direction. Number three, which is just as important, must be on one another. So what does one on one another mean? That means ball exert on ground. Ground exert on ball. You see now, ball, ground, ground, ball. That is what we must look for. Now let's examine the others. Why is it wrong? Especially like A, right? The force, the force that the ball exerts on the ground is always equal to the weight of the ball. So some people tell me, why is that wrong? Because if a ball was on the floor, like this, at rest on the floor, then wouldn't the weight be pushing down on the table? So then the force that the ball exerts on the ground is equal to the weight. So why is that wrong? What do you think, Esther? Why is this wrong?
It falls and hits the table, so there's a force.
Very good. So when it falls and hits the table, right, it won't be the same force if it's at rest. Because if it's at rest, it's just the weight. But if, let's say, it falls with a certain speed, when it hits the table, it will exert a bigger force. Now, actually, why? Because you remember there's a change in momentum of the ball. So at first, it has, let's say, a momentum mv. After that, it will bounce back, so it has a different speed. So let's say coming is v1, coming out is v2, so it's mv2. So do you know what is the change of momentum? The change of momentum will be mv1 minus negative mv2. Why minus, right? Because momentum is a vector. So if you are going down, it's positive. Going up must be negative. So you are getting a change of momentum of m v1 plus v2. So this will be the force exerted by the floor on the ball, which according to Newton's third law will be the force that the ball exerts on the floor. So it will be a bigger force than the weight. If you don't believe, you can try dropping a ball on your hand from a big height. Maybe you can use steel ball, then you can feel the effect better. You will know it's going to be painful, right? But you just put it at rest on your hand, then it's not going to be painful. It's just the weight. But if it falls from a certain height, it hits your hand, you will sure feel painful one. You understand? Okay? Right, so in this particular question, if a cyclist is riding at steady speed, now steady speed means constant velocity, net force is 0 lah, but that's maybe not used later lah, but they're just talking about Newton's third law. So Newton's third law doesn't matter whether it is accelerating or constant velocity, it doesn't really matter one. So what is equal and opposite to the backward push of the back wheel on the road? So Yu wants to answer? Wow, very good. Now, because the reason is in Newton's third law, you must have equal and opposite forces, yes, but we won't be able to see the magnitude. But the clue here is you must look at the third condition, which is force that A exerts on B equals to force that B exerts on A. So here, the object is back wheel on the road. So therefore, the answer will be road on the back wheel. Okay? And anyway, this is backward, so this is forward. So therefore, they are opposite directions as well. For this question, they want you to find the acceleration of the box. Now, to find the acceleration of the box, now most people would know that to label the weight here, which is 2 kg times 9.81, and they probably can also figure out that the frictional force 6 newtons is exerting on the box, so they'll draw it to the left. But most students will then follow this working. They will take the 2g, they will minus the 6 newtons to get the net force. So why can't I take the 2 times g and straight away subtract the 6 newton? Why cannot? Cheng En, why cannot?
Because it's not a straight line.
Very good. Because the weight is vertical downwards. This is horizontal to the left. Two vectors, they are not parallel to each other. You cannot just subtract their magnitude. If they are not parallel, you actually must draw a vector diagram if you wanted to subtract the two vectors. So therefore, you cannot do 2g minus 6. So what would be the correct way then? You can actually separate the two objects. 2 kg mass will be by itself. So what are the forces acting on the 2 kgs? I'm drawing a free body diagram only for this mass. So there will be a weight acting, and at the same time there will be a tension of the string acting upwards. Now, the equation therefore would be, since when you let go it's going to fall downwards, that means the net force is going to be downwards. So 2g minus the tension equals to ma, which means 2a. Now, for the box though, we have to draw a separate free body diagram. So what are the forces acting horizontally? Your tension this way and the 6 newtons here. Once again, we don't have to care about the weight and the normal reaction because the box is going to accelerate to the right horizontally. So any vertical forces will not affect your horizontal motion, so we can ignore it. So the question next is the tension here and here the same? What do you think? Is the tension along the string constant? It is always constant if they use a smooth or they say frictionless pulley. If there's friction in the pulley, then the tension on both sides will not be the same. But fortunately, for A levels, it's usually a smooth pulley lah. So therefore, for the mass here, 2 kg mass, it feels the tension here. For the 8 kg mass, it feels the tension here. So for this system, you'll be T minus 6 equals to 8A. Now, even though they're moving in different directions, one to the right, one downwards, but their acceleration should be the same, magnitude-wise. So therefore, I will do a separate equation for here, and also a separate equation for here. The magnitude will be the same, so I can solve simultaneously. So when I solve simultaneously equation 1 plus equation 2, the negative t plus t will cancel. You get 2g minus 6, and then you get 10a, and you will get the acceleration. Right, our next question is about Newton's laws of motion. So if you look at the options here, A, which is correct. So A, first law follows from second law. That means, right, after the second law comes the first law. B, it says the third law follows from second law. That means after the second law comes the third law. C, it says that conservation of energy is a consequence of third law. And D, conservation of linear momentum, is a consequence of first law. It's a bit confusing here. So, Omeo, what do you think is the answer?
A.
A, very good. Okay, not many people can actually get this answer because it's quite tough. So, the reason why the answer is A, right, it seems weird because, right, first law follows from second law. That means what? Second law comes first, then first law. Now, how come? The reason is because the second law tells you about the the long definition, the rate of change of momentum is directly proportional to the net force and stuff like that, right? And takes place in the direction of the force. In short, it actually gives you the formula F equals to ma. I mean, it leads to that formula, and it actually tells you that when there's net force, there will be acceleration. That's basically what they're trying to say. Second law, when there's net force, there's acceleration. But if you remember Newton's first law says that the body at rest or moving at constant velocity will remain in that state, right? Unless a net external force acts on it, right? So what it means is, therefore, when there's no net force, there is no acceleration. Because at rest or moving at constant velocity means no acceleration. Do you understand? So can you see how they link together? Second law says when there's net force, there's acceleration. First law then says, therefore, when there's no net force, there is no acceleration. So it is not as simple as like B. After 1 is 2, after 2 is 3, after 3 is 4. This is not like, kindergarten, right? And similarly, C and D are wrong because if you wanted to know the conservation of linear momentum is actually a consequence of the third law. So by combining the C and D, right, you can get the correct answer. Conservation of linear momentum is a consequence of third law. But in order for you to see that, later I'll show you a question that we can derive that. So in this question, if you have a golf ball hit by the club, now this is the force exerted on the ball by the club. All right, and you'll notice that this is the force, and it makes sense because as you hit the ball, you will start from 0, then you will rise to a maximum, and then when the ball leaves the club, you will drop to 0. So for this graph, right, which quantity cannot be found from the graph? Abel, what do you think is the answer? D, maximum acceleration. Why cannot know the maximum acceleration?
Because mass cannot be found.
Correct, because mass is not known here. So you cannot find the acceleration. Because acceleration, right, you must get from F equals to ma. Now, you can get the maximum force, but if you don't know the mass, you can't find the acceleration. But let's go through the others. Why is it the other answers actually can be found? So that means it's not the answer. Now, the average force, in case you're wondering how to find the average force, you take the 0 here, which is the minimum force, plus the maximum force, and then divide by 2, so you can actually find the average force. So that is not a problem. Now, change in momentum. In case you're wondering how to find change in momentum, remember the formula for force is rate of change of momentum, right? So change in momentum will be therefore F times T. Now, if the force is constant, you can straight away apply the formula, substitute a constant force, that means it's like a straight line like this, and times the T, you'll notice you get a rectangle, right now. But if it's not a constant force like this, you can actually still find the change of momentum using the area. So it is still possible to find a change in momentum. And the next one, contact time, is as simple as just reading this. All right, so that's why the answer is D. Now in this question, when the strong wind hits the wall, they want you to find the force exerted by the air on the wall. So you remember the force can also be obtained from this formula, which is the rate of change of momentum. Now, why would I know that I should start with this? Because they did mention to me the initial speed, and then they did tell me the final speed. So I should be able to calculate the initial momentum and the final momentum. And the final momentum will be 0. So I can use the rate of change of momentum. Now, unfortunately though, if you use the formula force is equals to the rate of change of momentum, you will notice that the momentum being mu, m is not given. So without the mass, how are we supposed to find the momentum? Now remember, right, if you are given density, you can find the mass. So Ryan, how do you find the mass from density? What's the formula for mass in terms of density? if density equals to mass divided by volume, so mass will be equals to density times volume. So that's what we start off first. So we change the M here to density times volume. Right, this M is density times volume. This V is volume, and this is speed. But volume is also not given to you. So don't worry though, if you assume the wind hits the wall, right? Like all this area of the wind times the distance, so this volume of the wind hits the wall, wouldn't the volume of the wind hitting the wall be the cross-sectional area times the distance it travels? So you can break down the volume to the area, cross-sectional area times the distance it travels. And then you realize something, the d over t, which is the distance traveled by the wind, over time is also the speed, right now. So therefore, we will get d over t, which is your speed. So speed times speed, get u squared. So in other words, your force is power squared. P no lah. Rho au squared. So rho au squared, can you use it for all cases? Actually, as long as it's a fluid like air or liquid hitting a surface, provided it stops, you can use this. All right? If you want to remember and memorize this formula, go ahead. If you don't want, also can. You can just derive it. So just substitute the density, the area, and the speed. Then you square the speed and you get the answer.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.